we're going to look at an introduction to logarithms, what logarithms are, and evaluating them, changing from logarithm to exponent form, and solving some equations dealing with logarithms. All right, so a logarithm, this may be brand new to some of you. It's actually the inverse operation of exponential functions. So, you know, the inverse of addition is subtraction, inverse of multiplication is division, inverse of squaring a function is to take the square root. So we're looking at the inverse of exponentials. So what undoes an exponential? So we can actually take an exponential function and write it in logarithmic form. We're going to combine those, the two concepts here. So if y equals b to the x power, so b meaning base, so the base, if y is equal to the base b to the x power, then log base b of y is equal to x. So this is just kind of figuring out like how to rewrite. So we're just going to look at a couple of examples like that. The other thing here, if y equals e to the x power, then ln y equals x. This may also be new to you. A lot of you know what the number pi is, 3.14, etc. E is a number like that, where it's just this number that exists. It's 2.178 and goes on forever, just like pi does. So it is a number. You could play with it in your calculator, type it in. But ln is called a natural log. So ln is the natural logarithm. And we call logarithms logs. So it's the natural log. So if you hear me say ln, that's what I'm referring to. It's just a logarithm that has base e. All right, so we're going to look at a few examples, right, as an exponential function. So we're just going to use this definition up here and rewrite. So the base is 9. The exponent is 2. So if you look here, base is here, exponent is here. So 9 to the second power equals 81. Which of course we know is true. 9 squared is 81. Just base, exponent, value. Here, the base is understood to be e. Exponent's over here. Value is x. So you can, and again, you can just kind of look at this, convert it to this. And then we can do the reverse as well. So here the base is 3. So we're going to have a log base 3 of, over here is the exponent, equals that value. I just lost my train of thought here for a second. I'm sorry, yeah, so the value, I was looking at the x and anyway, my brain got scrambled for a minute. So y, if we plug that in here, that's the value, log base b, so that's 3, of the value, which was the y value, 127 is equal to -3. So 3 to the -3 power is equal to 127. If you haven't seen negative exponents, or if you've forgotten with negative exponents, you just take the reciprocal. So it's 1 over 3 to the third power. 3 to the third power is 27. So that's where that 1 over 27 is coming from. We'll see that down here too. All right, so in this one, the base is e, so we know that we're going to use a natural log. So ln, and I don't need to write that e. I can just write ln of y equals 8, the exponent. So again, just using that formula, the value is y. So ln of y is equal to the exponent x. All right, so it's really just rewriting them and plugging them in. And the more you see of those, the more it will just kind of roll off. All right, so this one we want to actually evaluate. Notice it's not an equation, it's just evaluate, so find the value. What this really means is 5 to what power, because if you made it into an equation, it'd look like this. So to what power, x is that power, is 1 over 125. So 5 to the third power is 125, but because this is a fraction, I know that it's a negative exponent. So it's going to be 5 to the -3 is equal to 1 over 125. So the answer to this is -3. It's what power for 5 gives this value. Okay, so this last part, I'm going to change color marker here. we should have done that before. But we're to solve for x, I'm gonna convert these into exponential equations. It'll be a lot easier to deal with exponents, exponential form than the logarithm. So I'm gonna convert this. So if I convert, I'm gonna get x to the 1/2 equals 8. So that's the first step. Then remember, if you recall, 1/2 just means square root. So I'm gonna rewrite this as the square root of x equals 8. And then to undo a square root, we square both sides. So we're gonna get x equals 64 for that one. So it's really just a matter, if you're asked to solve a logarithmic equation, just rewrite it as an exponential and go from there. All right, this one, we're gonna rewrite as 7 to the negative 2 equals x. And then this one's a little bit easier, negative 2 power, that's just 1/7 squared equals x. So we get x equals 1/49. And that's it. So that is our answer to that one. So again, that's kind of a little introduction to logarithms. We're going to see how we can actually use logarithms to help us solve equations in a little bit. They're very useful, especially like we saw it in the last video where we were trying to, or we were looking at problems with the principal and exponential growth. So we can use logarithms to help us figure out what the exponents in those equations are using some logarithmic properties. So that's where we're headed in the next video. All right.